looking at notes N-2 trig functions with constraints. Before we get to today's lesson, I want to refresh your memory about M-2, 6 trig functions. So in M-2, we were dealing with xy as a point on the unit circle. However, today we'll be dealing with points that are both on and off the unit circle. But what I want you to be aware of is whether or not the point is on the unit circle or not, these hold true from SOHCAHTOA. So remember that sine of theta is y over r, because no matter if r is 1, we're talking about right triangles within different circles, whether it be the unit circle or not. Sine comes from opposite over hypotenuse, and if this is theta, our opposite will always be y, and our hypotenuse will always be the radius, whether it be 1 or not. So sine of theta will always be y over r, where r is the radius. Similarly, cosine of theta will always be, from ka in SOHCAHTOA, will always be adjacent, so x over hypotenuse, which is r, so on and so forth. So we're really going to be dealing with these a lot. And again, sometimes it will be on the unit circle and sometimes it will not. So you might want to have these handy. Okay, so remember, r is distance. R is the radius of the circle. It's the hypotenuse of the triangle, but it is the radius of the circle. So it's distance, it's always positive. Remember, the x and the y can be negative, they can be 0. They're points on the graph. They're location, they're not distance. So x and y can be negative, however, r will always be positive. So find all 6 trig functions given in number 1. Cosine of theta is -4/5, so this is not on the unit circle, as you know, okay, where theta is in quadrant 3. So let's refresh. So cosine, remember, is x over r, so I'm going to write that next to it so you remember. We know that the negative will go with the x because there's no way it can go with the r. The r has to be positive. Sometimes we'll have to bring the negative down, but in this case we won't because r has to be positive. We know that theta lies in quadrant 3, so I'm going to go ahead and draw this. We know that the angle lies in quadrant 3, so somewhere here. Okay, so to start drawing our triangle, we know from our starting point we're going to go -4, our x is -4. We don't know what y is. We do, however, know instead of going up, we're going to go down because we have to be in quadrant 3. Okay, so we went left for x. We know we're going to have to go down for y. We just don't know how much. And we know that r is 5. So we need to find this missing value here. So remember that we can use Pythagorean Theorem where we have the x squared plus y squared equals r squared. So x squared plus y squared, we don't know what y is, equals r squared. So 16 plus y squared equals 25. Of course, we're going to move this 16 across the equal sign, so subtract. So 25 minus 16 is 9. And then, of course, to get rid of the squared, I just rewrote this so you can see the progression here. Square root both, so we get absolute value of y equals 3. To get rid of the absolute value, we have plus or minus. Now, of course, you're going to look at our restraint, constraint. Okay, so we have that we are in quadrant 3, so that means my y value will be negative. So now I have filled in the missing piece here. -3 will be my y value. So now I can find all the other 6 trig functions. So recall that sine is going to be your y over r. So y is -3 over r is 5. Cosine of theta we already knew, but let's just verify, should be x over r, so -4 over r, which is 5, so yes. Tangent is y over x, so -3 over -4. Of course, -3 over -4 is going to turn into positive 3/4. Cosecant, remember, is the reciprocal of sine. Cosecant is going to be your r over your y, so 5 over -3, so in other words, -5/3, reciprocate this, or you can look at the triangle. Secant is the reciprocal of cosine, so -5/4, or in other words, our r over r x. Okay, and then cotangent is the reciprocal of tan, Okay, so that is going to be our x over y. So negative 4 over negative 3, which is going to turn to 4/3, the reciprocal of tan. So it all worked out. So box these up. These are our 6 trig functions for number 1. Okay, now let's look at number 2. So cosine of theta equals 8 over 17, where tangent of theta is less than 0. So a couple of things. Cosine, remember cosine is our x over r. We're dealing with positives here, yay. Okay, tangent of theta is less than 0. So remember, tangent is y over x. So y over x is negative. If we're talking about quadrants for this, remember, for a number over a number to be negative, only one of them can be negative. So what quadrants do we have only one negative value? This quadrant, second quadrant, and the fourth quadrant. Okay, but here's the deal. We already know x is positive, so it cannot be the second quadrant because x is already positive. It was given in the problem. So it must be that our y value is negative. So we actually already have like a leg up because we know our y value must be negative. It's got to be this quadrant. So I can start drawing my triangle. I know that from my starting point, I'm going to go positive 8, so to the right 8. We don't know what y is, but we do know it's negative, so we'll go down. And then we know that our r value is 17. So let's find this piece that we don't know by utilizing our Pythagorean theorem. So x squared plus y squared equals r squared. So 8 squared is 64. Plus y squared equals 17 squared is 289. So move over the 64, in other words, subtract 64. So y squared equals 289 minus 64 would be 225. Again, showing the progression, that's why I'm rewriting this. Square root both here, we get absolute value of y equals 15. Y equals plus or minus 15. But of course, we already know what quadrant we're talking about. We knew we had to have a negative y value because one of the two of these had to be negative for this whole thing to be negative, and x was already positive. So we know our missing piece is negative 15. And just like you did up above, find all the 6 trig functions. So finish. I don't want to waste any more time on the video, but you should know how to do all this because it's been in this video and the last video as well. Okay, so let's get you started on number 3. Cosecant of theta equals 4. Again, 4, we're not talking about a point on the unit circle. Unfortunately for this problem, we cannot utilize the unit circle. So remember, we can write 4 as 4 over 1, and cosecant is the reciprocal of sine. Remember, one co per pair. Cosecant is the reciprocal of sine, so we're talking r over y. Okay, r over y. And here our constraint is that cotangent of theta is less than 0. Remember, cotangent is x over y. So x over y is negative. Similar to when y over x is negative, we're talking quadrants that either one or the other of these is negative. Not both, because that would make a positive. So we're talking quadrant 2 again and quadrant 4. And then again here we have another hint. This is positive. That means y must be positive. So if one of the two of them has to be positive and one of them has to be negative, that must mean we're talking about this quadrant here. Because y is already positive, x must have to be negative. So we know it's got to be that quadrant. Let's start drawing our triangle. So for our triangle, again, we know the x value is negative. So from our starting point, we're going to go left. We don't know what the value is yet. We know it's negative. We know our y value is positive. I probably should have drawn it a little lower. So x value is negative, our y value is positive 1, and we know our r value is 4. Let's find out what the x value is. So we don't know what x is, so I'm going to scoot it up a bit for more space. X squared plus y squared equals r squared. So x squared plus 1 equals 16. Of course, we want to move over that plus 1, so subtract. So x squared equals 15. So to show the progression here, square root both sides. So absolute value of x equals plus or minus 15. But again, oops, hello, I'm getting ahead of myself here. X equals plus or minus square root of 15. So here we know we're talking negative because of what quadrant we have to be in. So we know that our x value is negative square root of 15. So again, for sake of time, you have the triangle, you have the resources, you could finish this and find out the 6 trig functions. All right, so let's move on now to some that may be on the unit circle. Yay, that'll help us out. So sine of theta equals 0. We're talking unit circle here when we see 0. Remember sine is y over r. Okay, we could honestly put anything under here, because 0 over 2 is 0, 0 over 4 is 0, 0 over negative 1 is 0. Of course, r can't be negative. But since we can make r anything, let's make it the unit circle. Let's make it 1, okay? So if sine of theta equals 0 over 1, we're talking unit circle. Okay, so drawing that unit circle, where on the unit circle is sine of theta equal to 0? In other words, where are the y values 0 on the unit circle? Okay, so the y values on the unit circle are 0 here at negative 1, 0, and here at positive 1, 0. And this was supposed to have a constraint. I'm so sorry it doesn't. Secant of theta equals negative 1. This was also supposed to have a constraint. Pi, there we go. I missed that. Okay, so we have two possibilities on the unit circle here. It could be negative 1, 0 or 1, 0. Those are the two places where sine of theta on the unit circle is 0. So our constraint will help us figure out which one to use. So we know secant of theta equals negative 1. Well, secant is the reciprocal of cosine. Okay, so we know that we know that cosine is the reciprocal. So cosine of theta equals the reciprocal of negative 1. Well, y'all, the reciprocal of negative 1 is negative 1. So cosine of theta equals negative 1. Again, cosine is x, so x has to be negative 1. The only point where x is negative 1 and y is 0 would be this point on the unit circle. So now you would have your x, your y, and your r. You could draw your triangle if you wanted to, if you needed to. So your x is negative 1, your y is 0, and it's the unit circle, y'all. So the r value is 1. So negative 1 for x, 0 for y. It's the unit circle, so the radius is 1. And from there, you could finish. Okay? We also have on number 5 the lucky fact that we could be talking about the unit circle here. Tangent of theta equals undefined. Okay, so tangent of theta equals, we know in order for something to be undefined, it's got to be over 0. Okay, now we don't know what this is. It could be anything. Okay, but we do know for it to be undefined, this is over 0. So our x value, because remember tangent is y over x, has to be 0. All right, so again, we could be talking about the unit circle here. Okay, so where on the unit circle do we have x values of 0? Two places. Here and here we have 0, 1 and 0, negative 1. Which one are we talking about? Are we talking about where y is positive 1 or where y is negative 1? Well, let's use our constraint to see if that helps. We know based on the constraint that theta lies between pi and 2 pi. Well, here's pi, here's 2 pi, If it lies between pi and 2 pi, it's got to be somewhere between here and here. So that must mean we are talking about this point here. So again, if you wanted to draw your triangle, you could. We know that our x value is 0. We know that our y value is -1. And because we're talking about the unit circle, our r value is +1. So x value is 0, y value -1, r is 1, and then from there you could finish. Okay, last two here. I know this is a lot. Cotangent of theta equals -3. Okay, we're not talking about the unit circle. -3 is not a point on the unit circle. So we do know cotangent is x over y. We know that -3 can be rewritten as -3 over 1. Okay, we know our quadrant 2 looks like this. So let's think about our circle. Our triangle. Here's the deal. This really could be -3 over +1, or it could be +3 over -1. But the quadrant 2 tells us what it's got to be. It's got to be that x is negative and y is positive. So that helps us. So when we draw our circle, we know we're going negative, or triangle, I think I keep on saying circle. -3 for x, y is +1. We don't know r. Okay, so you have to find r. So we're going to use Pythagorean Theorem. So we know x squared, -3 squared plus y squared equals r squared. We want r, not r squared. So we are going to end up square rooting both sides. So this would be 9 plus 1, which would be 10. So square root of 10 equals absolute value of r. So plus or minus square root of 10 equals r. But of course, y'all know r is distant, so it can't be negative, so it's got to be positive. So this would be square root of 10. So then, of course, you want sine of theta. So in this case, sine of theta equals y over r, so 1 over square root of 10. Can't have that square root in the denominator, so rationalize, and you would get sine of theta equals square root of 10 over 10. All I wanted was sine of theta. Last one, cosecant of 3 pi over 2 equals question mark. This is on the unit circle. 3 pi over 2 is on the unit circle. Lucky you. Love these that work out this way. So 3 pi over 2 would be this point here. Okay, this coordinate is 0, -1. Cosecant is the reciprocal of sine. Cosecant would be r over y. Okay, so r over y, we're talking cosecant of 3 pi over 2. R, the radius on the unit circle, is 1. Y is -1. So cosecant of 3 pi over 2 is equal to -1.